So from our overall equation, we're going to write down the ionic equation. You should know how to do this. Copper, copper metal, okay, silver nitrate, an ionic compound, so made up of these ions. You don't need to put the 2 in there at the moment until we come with the overall equation. Silver metal, copper nitrate, ionic compound, made up of these ions. So, looking at the state symbols as well, you should be able to see what is the spectator ion, the nitrates. So, we can get rid of those. What you're left with is the ionic equation. Not quite though, we haven't finished yet, because in ionic equations, as well as balancing for particles, you really need to balance for overall charge, which is going to be useful when we come to write more complicated ionic equations. So on this side you can see at the moment we've got a charge of +1 because of the silver ions. But on this side you've got a charge of +2 for the copper ions. How are we going to remedy that? 2. But now I have to have 2 there. And if you look back, that's the same balancing as your original equation. So, what are redox half equations? It tells me what happens to one of the reactants at a time. So, let's have a look at the copper. So, copper, what does it end up as? Cu2 plus ions. How is that possible? The copper metal lost electrons to become copper 2 plus ions. This is one of the simplest redox half equations. Half equation because it just shows me what happens to one reactant. Redox half equations will always have electrons somewhere. Now we can write down what happened to the silver ions. Silver ions, they ended up as silver metal. Now, how is this possible? The silver ions must have gained electrons. Where from? Well, they actually gained the electrons from the copper. Okay, but you can see it's not quite balanced yet. So, how do we get the overall ionic equation back? Well, we have to make sure that the number of electrons lost by one reactant is equal to the number of electrons gained by the other reactant. So how is that going to be possible? Well, we have to multiply this half equation times 2, so that overall the 2 electrons lost by the copper atoms are going to be 2 electrons gained by silver ions. Okay, so we would end up with 2Ag plus 2 electrons goes to 2Ag. Okay, and if you have a look at now, looking at these two half equations, can we put them together? If you put them together, you should come up with the overall ionic equation. Let's have a look. So, copper, on this side, what do we have? Copper plus 2 silver ions plus 2 electrons goes to what? 2 silver from here. What are the products from the other half equation? Plus Cu2 plus 2 electrons. Can I cancel something out? The overall electrons. Okay. Another thing that you should be able to notice is the copper lost electrons. So, copper is oxidized. Yes? this. What happened to the silver ions? Ag plus ions gained electrons, so they are reduced. It's really important that you write it like this, and you do not just say, silver is reduced. A very common mistake. What do chemists mean by silver? The metal. What gained electrons? Silver ions. So you must make sure that you write that very clearly in your answer. Okay. Something else that we will come back to at the end to show you, just to be 100% sure. Copper is oxidized because it lost electrons. I could also say that copper is the reducing agent because it gave its electrons to the silver ions. Okay. So make sure you understand this, a bit of revising from grade 11. Now we're going to try a couple of more examples of applying this. I'll stop when I do